Okay, guys. Good morning. So today we'll start something kind of new. I mean, not new in the sense that we've never solved equations before, but these are definitely going to kind of look like different equations. And we're going to solve them pretty much the same way we've solved everything else, but they are going to at least look like different equations. So just prepare yourself, right? So for our do now, I'm going to do this kind of quickly here. So if I'm doing the first one, it looks like I'm going to get 9x minus 18 equals 9x plus 18. So we talked about this previously, right? If I have the same variable term but different constants, when I eliminate that variable term, it's going to leave me negative 18 equals 18, which is obviously not true. That means this will never be true, and we've got no solution. All right, let's take a look at the second one. When I combine those like terms, on the left it looks like I've got x plus 1, and here I've got negative 4x plus 1. Well, I can solve that, right? I can add 4x on both sides, and I get 5x plus 1 equals 1, and I can add negative 1, and I get 5x equals 0, so x equals 0. Well, that's a solution, right? X is 0 is a number, just like any other number. It's unique in the sense that it has no sign, but it is absolutely a solution. And let's look at the last one. So when I combine all these x terms on the left, I get negative 10x. When I combine everything on the right, 1 and negative 1 is 0, I get equals negative 10x. Now, as far as I know, negative 10x is always equal to negative 10x. And I will say I have infinitely many solutions. All right, so let's talk literal equations. So what's a literal equation? Well, it's an equation that you're going to solve, but you're not going to get a numerical answer. Right, so we're not going to get x is equal to 15. We're going to get x is equal to 3y minus 7, let's say. So how would we solve for x? Well, the same way we would have solved for x yesterday, right? Or, when we did equations, when we solved 1 or 2 step equations, I need to isolate x. Okay, I don't want that 2y to be there. I need to eliminate it. So I'll eliminate it, right? We know we can eliminate anything by adding its opposite on both sides. So 2y plus negative 2y is 0. And z minus 2y is z minus 2y. That's it. Okay, so, some of these are going to be multi-step problems, but in the general sense, guys, how do we solve a literal equation? The exact same steps we would, use for any other multi-step equation. Okay, what would I do if my equation said 5x was equal to 30? Well, I would divide both sides by 5. Well, this is no different. So I want to solve for x. I don't want 5x, so I divide both sides by 5. So 5x divided by 5 is x, and y divided by 5 is y divided by 5. Now, if you wanted to think about this as y is equal to 1y, you could also write this as x is equal to 1/5 y. Okay, because 1 divided by 5 as a coefficient is 1/5. So I would go with this one, right? Y divide 5, but if you put 1/5 y, that means exactly the same thing. So what are our guidelines? Now, obviously, different problems, might have some different parameters to them, but in a general sense, move the terms to get the specified variable by itself. In other words, isolate the variable, so that's nothing new. We've been doing that for a month. Divide by the coefficient, and that's nothing new. We've been doing it for a month. Now, what I was saying a few seconds ago about, case by case, or some equations might be a little different, is if we have a fractional coefficient, there's something else that we've talked about quite a bit that we're going to do instead for number 2. But this is what we're going to grab in our notes as far as how do we solve with variables in the answer. So I wouldn't even really say it's in the answer. I would say it's on the right side. Okay, so how are we going to solve for a? Well, the first thing we have to do is we need to isolate the a term. So I need to add negative 7 on both sides, which is going to give me 2a is equal to y minus 7. All right, well, I don't know why that where that came from. Sorry, so 2a is equal to y minus 7. Let's divide both sides by 2. So 2a divided by 2 is a, and y minus 7 divided by 2. I'm just going to leave as y minus 7 divided by 2. All right, so really when we write this, I don't know why this is getting a little off for me. We're going to write it like that. So a is equal to y minus 7, the quantity divided by 2. All right, this is really going to be no different. I need to isolate my a term, so I'll add negative 12b on both sides. Now, one of the things that we probably should understand is that I can write any expression with a negative in 2 ways. I can also say 4a is equal to negative 12b plus 8. So what's the takeaway here? Well, if I want to write, let's say, something like a minus b, and you want to write negative b plus a, they mean the same thing. As long as the a is positive and the b is negative, the order of the terms is not important. So if I want to say 5 minus 7x, maybe I'd rather say negative 7x plus 5. They mean exactly the same thing as long as the 7x is negative and the 5 is positive. So getting back to this problem, I'm going to divide by 4. So 4a divided by 4 is a. But I can divide 8 by 4 to get 2. And I can divide negative 12b by 4 to get negative 3b. So if you want to leave it as 8 minus 12b divided by 4, I'm fine with that. But we want to check and see if these things are divisible. Now, you wouldn't want to do it for one of them but not the other necessarily. So if I had 8 minus 13b, I'm not going to say, well, 8 divided by 4 is 2, and then, you're in a weird spot. Okay, so in other words, I would only really simplify this, and there's lots of different examples we could see, so there'd be a lot of cases to examine, to go case by case, but I think I provide a good amount of them here that we'll see, where if it is evenly divisible, we're going to divide it out. Okay, and that's going to come into play a little bit here as well. So I want to solve for a, so I add negative 3b on both sides. So here I'm going to write it a little bit different. I'm going to write negative 3b plus 20. Okay, so again, could you write 20 minus 3b? Sure, it means the same thing, but I'm going to write negative 3b plus 20. So now I need to divide both sides by 5. Okay, now, what am I going to notice here? Well, 20 is divisible by 5. So one thing I can do is, I could do nothing. I can leave it. I can say a is equal to negative 3b plus 20 divided by 5, and that would be perfectly fine. But I think we can do better. So what I'm going to do is I'm going to say, well, I can divide negative 3b by 5. And it's going to give me negative 3/5 b. And I can divide 20 by 5, and that's going to give me 4. Okay? So if you're looking at this and you're saying, I don't really understand that yet, then just do with what works for you. We're going to stick with what's simple. The reason I like this is when we start graphing in a couple weeks and when we need to solve equations for y, what's called slope-intercept form, which some of you guys may know about, we are going to have to eventually do this. Okay, so I did want to introduce it to you, the concept of if you have something like, let's say 5x plus 12 divided by 4, I can do 5x divided by 4, which is 5/4 x, and 12 divided by 4, which is 3. Okay, so just something to think about. Again, is it necessary today? No. Again, this up here is perfectly fine. But going forward, eventually we will have to start simplifying it in this sort of method. All right, so now we have two coefficients, right? In other words, if you're thinking about b as your variable, and of course a is a variable, the coefficient of b is technically 3a. So what can we do to solve for b? Well, I guess we could divide by 3 and get ab equals 11/3 and then divide by a, but to me that seems really inefficient. So if I want to just solve for b, I need to divide by what I don't want, which is 3a. So let's look at what happens. 3ab divided by 3a. Well, 3 divided by 3 is 1, and a divided by a is 1, so this just leaves me with 1b equals 11 divided by 3a. So if you have more than one coefficient, okay, and 3 is the numerical coefficient, but we can think about a also as like an algebraic coefficient, you have to divide by both of them, and we do not want to do it in steps. If you divide by 3 and then divide by a, we have this mess. This is a complex fraction. I don't think anybody wants to simplify that, okay, when we can just in one step get our more simplified answer. All right, so let's take a look at this one, solve for b. All right, well, b is not by itself, right? It's not isolated. So I've got 6b is equal to 5a plus 4a is 9a plus 7c. I'll divide both sides by 6. So I'm going to get b is equal to 9a plus 7c divided by 6. Can I simplify the 9 and the 6 by dividing by 3? I suppose, right? In other words, but then I'd have to divide the 7 by 6. So that would give me 3 halves a plus 7 6c. I don't think anyone really wants to mess with that, so I would just leave this one as is. All right, and this one is going to throw back to one we did 2 examples ago, that 3ab equals 11 question. So how would I solve for b? Well, at some point I'm going to have to divide by 12, and I'm going to have to divide by A, and I'm going to have to divide by B. So really what I'm going to do is I'm going to divide by 12AB. Right, so on the left I've got 12 divided by 12 is 1, A divided by A is 1, and B divided by B is 1. So I'm just left with, oops, let's try that again. I divided by the wrong variables. Okay, so I want to solve for B. Why did I divide by B? I really don't know. I'm going to divide by 12AC. So what happens when I divide by 12AC? Well, 12 divide 12 is 1, and A divide A is 1, and C divide C is 1. I'm just left with B. What am I left with on the other side? Well, it's just x plus y divided by 12AC. So not that different than the 3AB example, except we had an additional variable, okay, which was 12ABC, so we had to divide by 12AC. Okay, so for this one, right, this is why when I gave you those two steps at the beginning, I said, yeah, the second step is divide by the coefficient, but we know we don't do that with the fractional coefficient, right? What do? And I know you guys are sitting at home screaming at your screen. We multiply by the coefficient, which is exactly true. So the reciprocal of the coefficient. Sorry, I know that's what you guys screamed. You said multiply by the reciprocal, right? So the reciprocal of 1/2 is 2 over 1, which I'm just going to call 2. So when I multiply 1/2 of 2, I get 1, so just 1b, and 2 times 8a is 16a. So someone always asks at some point, can we check these, right? And then everyone gives them a glare, like, why would you say that? Now the guy's going to make us check them. So the answer is, of course, you can check them, but I would never require you to check. But if you wanted to check, you'd say, let me rewrite the original, because this is an easy one to check. We think that b is equal to 16a, so let me replace b with 16a. And let me see if it works. So half of 16a is 8a. So just in case you're sitting at home bored saying, wow, I really want to do more, maybe I should check these, they are going to, of course, be checkable, but that's not something I'm requiring you guys to do. All right, so again, right, what do? And you guys are saying we multiply by the reciprocal, and I'm saying wonderful. And then I'm saying, oh no, how am I going to do that over here? And then you're screaming, use parentheses. And yes, I'm going to use parentheses, which means I have to distribute. So when we distribute, the 4/3, we're going to do 4/3 of 6a, we're going to do 4/3 of -12. So on the left side, 4/3 of 3/4 is just 1, so that's going to give us c. And I'm going to do 4/3 of 6a, which is 24/3a, which is 8a. And 4/3 of -12, which is -16. So we get c equals 8a minus 16. All right, let's take a look at one more. So this one has a little extra to it, right? This is the formula for the volume of a cone, 1/3 times the area of the base times the height. So we have to do two things here, right? We have to eliminate that fractional coefficient by multiplying by the reciprocal. So the reciprocal of 1/3 is 3. That's going to give me 3v is equal to bh. And if I'm solving for h, I need to divide both sides by b. So my final answer should be that h is equal to 3v divided b. All right, guys, so that's your now try. Okay, so I don't think these are terribly difficult considering we did a whole bunch of examples. So you're going to pause it now. All right, guys, so then we can come back and I'll work through them. So for the first one, the only thing we need to do to solve for x is we add 7y to both sides. So we should have x is equal to 7y plus 11, or 11 plus 7y. They mean the same thing. For the second one, the only thing we have to do is divide both sides by 4. So we get x is going to be equal to 9/4 y. The other two have a little bit more, or at least the fourth one does, right? So for this one, we're just dividing by the coefficient, which is -6. But I have to actually do the division now, right? So 30y divided by -6 is -5y. -12a divided by -6 should give me +2a. And then for the last one, there's a bunch of things we have to do, right? So if I'm solving for x, I need to move both of these terms. So I need to move the z term, which I'll put here, since we do have a like term there. And I'm also going to have to move the y term, right? So that's going to leave me with 8y minus 2x is equal to 12z. And I need to add -8y on both sides. So I need to make sure I bring down -2x is equal to 12z minus 8y. And I'm going to divide both sides now by negative 2. And we actually have to do the division because it is evenly divisible. So 12z divide negative 2 should give me negative 6z. And negative 8y divide negative 2 should give me positive 4y. So again, the rules are the same as far as the way we solve the equations, right? We isolate the variable, and at the end we either divide by the coefficient, or if it's a fractional coefficient, we multiply by the reciprocal. All right, guys, so that's your homework, right? You're solving each of them for x. So they all have some different variables in them. We're solving all of them for x. You don't have to check. Any questions, comments, concerns? As always, upload your homework, post a comment on Google Classroom, and let me know which ones you're having trouble with.